before when we've graphed. We've had a graph that looks like this. Here's your 0, here's your 2. And could somebody explain to me what that is the graph of? Yeah.
X is greater than 2.
X is greater than 2. Not greater than or equal to. If it was greater than or equal to, we would have to shade it in that circle, correct?
Correct.
And we've had equations, so we had to find what X is, and that's what our test is about. Okay? Well, today we are going to talk about something called compound inequalities. The work is not hard, but maybe the understanding of it might be a little bit tricky. Okay? And all that means, now there was one question on your test that I should not have put on there because it had to do with today's. And do you remember reading something on your test that said, solves this one or this one?
Yeah.
And I think some of you guys asked me, you know, what should we do there? And I said, we'll just solve one of them. And I'm not going to mark that one right or wrong. But let me tell you about that problem. Let's say that we have 3 and we have -4. And we have this. And we have that. Okay? So if you see a problem like this, the solution is x values could be greater than 3
Or less than.
or, and that's an important word, is that word or x is less than or equal to -4. It can't be and the reason it cannot be and is because you can't have a number that's greater than 3 and also less than -4. It's one or the other. Yes.
Can you put -4 first, or does it always have to be the constant number?
Oh, no, you can, it doesn't matter.
Okay.
I could write it x is less than or equal to -4 or x is greater than 3. So it could be one or the other, but not both. Right. But not both. And so that word or becomes important. And if you graph two equations on a number line, then it becomes a compound inequality. So what does an and statement look like, you think?
When two numbers are.
What do you think? What do you think an and statement might look like? Here is 0. Go ahead.
If you like 1, x is greater than 1.
X is great. Hold on. So you want to write x is greater than 1? Okay, and?
And then x is greater than 5.
No, not exactly. You're on the right track.
Oh, less than or equal to?
Less than or equal to?
5.
5, yes. And let me show you what that looks like. This is values where x, it's greater than 1, and also we want numbers less than or equal to 5. And that becomes an and statement.
So you don't put the x by.
Now, if you look at numbers that could work, any numbers that will work is any numbers greater than 1 and also less than 5. Let's pick a number in there. 4. Okay. Is 4 greater than 1?
Yes.
And it's also less than 5.
Yeah.
Okay, so it works. And this is called an and statement. So we have and or. And notice what the graphs look like, Aaron. Notice what the graphs look like here. Okay? We have an or statement. We have an and statement, yes.
You not put x after and?
So it's only when the lines are connected?
Well, here's the way we're going to represent this. If you take a look at what x is, can you tell me what x is between? We have all x values between what? between 1 and 5. And so we're going to write it this way. And look where x is located. X is located right between 1 and 5. But it could equal 5. But x is between 1 and 5. This, when you see a situation that looks like this, it's an and statement.
Can you write it either way or
No, no, no. We write it this way. This is an and. It's called
What
a
way?
compound inequality.
What's in the middle when you do?
And if you look at something like this, what we're looking at is the word or. And you have to have the word or in when you're graphing one like this, a compound inequality. So, let me show you, let me give you a couple of problems and a couple of examples of what it looks like when it's an or and what it looks like when it's an and. Now let's do the and first. Oh, let's forget that too. Okay? And look where that x is located. It's right in between two numbers, isn't it? All right. Well, we have to find out what x is. And is this going to be an and statement or an or statement?
And
This is going to be an and statement. So what it's going to look like when you graph it, here's your 0, it's going to be between two numbers.
2 and 9?
So we're going to, no, it's not going to be between 2 and 9. So what we have to do here is solve two equations. We'll solve this one where 2 is less than x plus 5. And we're also going to solve x plus 5 less than 9. So let's solve those two equations by subtracting 5 from this side here. Okay, do you see what I did? I took the middle term here, and I split it up into 2. Okay? And then here I'll subtract 5. Okay. So it looks like my two numbers are -3, which is over here, and 4, which is on the right side. Am I going to have open circles, closed circles, or one of each?
Open.
They're both going to be open. And because we have an and statement, it's going to be between those two numbers.
why is there a line in the middle of them?
Well, what the line signifies, Aaron, I need your head up. Thank you. What the line signifies is that it's telling you that all these values between -3 and 4, I could plug in for x, and they're going to work. So let's pick 1, which is between -3 and 4, correct? So if I put in 1 for x, I have 1 plus 5. This is telling me that 6 is greater than 2, and it's also less than 9. And it's right in between those two numbers. Okay? Yes, Austin.
How do we know it's and statement?
All right, that's a good point. How do we know it's an and statement? If you see a situation where it's set up like this, it is an and statement. Or you could see the word and.
Oh, okay.
How
Yeah,
would-
and means between.
How would you solve that 2 is less than 6 is less than negative?
No, I just put in 1 for x. You don't solve anything. All I did was I asked you to pick a number between -3 and 4. Somebody picked 1. So 1 plus 5 is 6. I just showed you that, and you asked me what this line was about.
Oh, yeah.
What this line is about is that all numbers between -3 and 4 will solve this inequality. Okay? Emily, you had a question?
I don't know.
Okay. right? So if you see something that's in between as an and statement, so what does it look like if it's an or statement? Well, let's do another and statement. Okay? So let's do one that's, let's do one out of the book here. -5 less than or equal to -x minus 3 less than or equal to 2. This one's a little bit tricky. Okay, so let's see what that looks like. First of all, what I'm going to do, -5 less than or equal to, Austin, is this an and statement?
Yeah.
Yes, because it's right between two numbers. So it's going to be between two numbers, and we got to figure out what those two numbers are going to be between. And here's my 0 right there. And -x minus 3. Also, I'm going to solve -x minus 3 less than or equal to 2. And those are the two equations I'm going to solve. And then I'm going to graph them. Adding 3 here, adding 3 here. And I have -x greater than or equal to -2. Now what do I have to do? Divide by -1. X is, what do I do with the sign?
Flip it.
And the reason, remember, when you divide by negative, you reverse the inequality sign. Dividing both sides by -1. Okay? So this says I want, can you read that for me? Yes.
2 is greater than, or no, yeah, greater than.
Read it from the X.
The x? Oh wait, x is less than or equal to.
X is less than or equal to 2. Here's 2. I want values of x that are less than or equal to. It's going to be between two numbers, isn't it? Let's find the other number. I'll go over to this one on the right, add 3 to both sides. And -x less than or equal to 5. Then what do we do?
Divide.
Divide by negative. What do I do with the sign?
Flip it.
So it becomes greater than or equal to -5. Here's -5 over on the left side. Open circle or close?
Close.
Close. And we have this and statement. This is the way I want us to write it.
You always have to draw a line between them for and.
Yes. Always. Because what it means, Carly, is that all these values between -5 and 2 will work. So I'm going to write it this way. Here's how you write the solution. There's -5, there's 2, and there's the x right in between the two. Because I want all of these numbers in between these two. I want values greater than or equal to -5, and also less than or equal to 2. Okay? All right. And let me give you one more example here.
The or one.
Your statement. Whenever you have an or statement, Luke, it's going to look like this. We're going to have 2x plus 3 is less than 9, or 3x minus 6 greater than 12. Okay? So you're going to actually see the word or. I cannot write it like I did the other ones. You're going to see the word or, and we solve those two, and then we'll graph it. So if I subtract 3 from each side, okay, I'll have 2x is less than 6. Divide by 2. Do I flip the sign?
No.
No, because I didn't divide by negative. So x is less than 3, or here I'm going to add 6. 3x greater than 18. Divide by 3. X is greater than 6. Okay, so let's see what that looks like. Here's my 0. We always put the 0 there. Here's 3. Here's 6. Open circle or closed? Open on both, right? This tells me I want all values less than, and I can put an arrow here. I want values that are less than 3 or values greater than 6. And you cannot write that as we did the other one. We cannot write that in that form.
Is that how we're supposed to write it? The answer to that?
You can't write that in this form. This is how we write an AND statement when it's between two numbers. And this is how we write an OR statement. You have to actually write the word OR. You cannot write it as between two numbers
And the
because
and
it's not.
statements, you just show it in the graph.
You show it in the graph, and this is the solution. This is what the graph looks like, and this is what the solution
And
looks
for
like.
the, what about for the and one? You just,
For the AND one, this is what the solution looks like, this is what the graph looks like.
oh, you have to write the solution.
Here's a solution, here's the graph. For the OR statement, here's the solution, and here's the graph.
Okay.
Yes, Austin?
So for the OR solution, you don't connect the graph.
That's correct, you do not connect them. You're going to have arrows.
Ever? Like, you would never.
That's correct, when you have an OR statement. Okay, does that make sense? Okay, and these are called compound inequalities. And this was lesson 6.4. Okay, so here's what I want you guys to do. On pages 384 and 385, problems 3 through 39.